Okay, so let's get started. So I asked the question, what is temperature? Okay, it's difficult to ask, just let me finish my thought. Difficult to ask, well, thank you for paying attention. Difficult to ask a question like that, temperature, in the first chapter we're doing, especially when it's on measurement, because you may not have a lot of former knowledge on temperature, right? Make sense? So how do you really have a discussion about temperature and chemistry when the chapter is on measurement? What? Significant figures, accuracy, precision. So why are we talking about temperature? Anybody?
Measurement?
Yeah, we're talking about it in terms of measurement. So what do you when you measure temperature, right? What do you do? Tell me, talk me through this. Yeah, well.
You measure the exchange energy.
Don't get so technical. I want to know from a practical point of view. I'm from Mars. I want to measure the temperature, and I say, how do I do that? Now you've got to be very specific in terms of how I do that. Okay? So walk me through this. Now I don't have to understand temperature, but I just want to know how to measure it. I don't care about if I know temperature. Yes? You get a thermometer. Excellent. What's the first thing you see when you see a thermometer?
Scale.
Oh, who said that? Excellent. So you get a thermometer, right? And you see a scale. Okay? Talk to me about the scale just for a minute. What do you see on the scale? Anything? Or?
Numbers.
Yeah.
Numbers.
You see numbers on the scale.
Units.
Units. What units do you see?
Celsius or Fahrenheit.
Celsius or Fahrenheit. Excellent. So you have to talk to them about Celsius and Fahrenheit. A little too complicated. But the point is what? The point is that you have a scale, let's say 30 to 40, okay? And let's say right around here, exactly, okay? What temperature is that?
37.
37? No. 37.0. You would receive 0 credit for that if you put 37, because this is plus or minus 0.1, right? Yes? So your measurement has to be to 0. Okay, good. So you're going to talk to them about what? You're going to talk to them about scales. You're going to talk to them about estimated place value, precision, when you use a 0, when you don't use a 0, when a 0 is significant, when it is not significant, when it's used to hold place value, right? Isn't that what you're going to talk about? So that when we talk about temperature, that's what we're talking about. So we don't necessarily have to understand temperature. We have to know what temperature means, maybe relative as a number. If I say to you, you've demonstrated in the class so far that you have an idea what temperature is, but you don't know it as well as you will at the end of the year. Would you say that's true?
Yeah.
Correct? Okay. So I say to you right now, it's 0 degrees Celsius outside. What do you think?
No.
Yes. I'm crazy. Yeah. What else?
Really cold.
It's cold. Yeah, it's cold. So you know temperature in terms of what? In terms of what?
Cold and hot.
Relative. In other words, I know what hot and cold temperatures are. I know what a temperature is from one day to the next, right? When it was in the winter time, it snowed out and it was like 0 degrees or -10, right? Now I come here to Abu Dhabi and I'm roasting, it's uncomfortable, it's 110. So now I associate 110 with something that's really uncomfortable. You know, Fahrenheit, I'm sorry, 42, whatever 110 is in Fahrenheit, okay, right? So you understand temperature in relative terms, correct? But let me tell you a little bit more about temperature because we're on it anyway, okay? Let me talk to you a little bit about temperature. Yeah. Let's define 2 words first, and this will surprise you. All right? This will surprise you, all right? Can I erase this real quick?
Sure.
Define the word, and ask your parents tonight. They won't know either. They won't know this. They won't know this. You ready? And they'll say, oh, I meant that. Oh, yeah, right. You ever hear the, oh, well, I meant that. Oh, well, that's what I said. Oh, really? In Martian? Okay, so define for me hot.
When there's a lot of energy being back and forth, and then you're gonna get mad at me for being technical, so I'm not.
I'm getting mad at you? Why would I get mad at you?
No, I'm gonna yell.
I'm going to yell?
What you do?
No, if I speak to you like this out in the hallway, that's not a good thing. You don't want to be spoken to like this. When I'm yelling, it means I'm actually very happy. Okay?
Oh, okay.
You get the difference. When you have to say, excuse me, you may not want to know what I said. Okay? So, hot, a lot of air, a lot of heat. Come on, let's go. Help me out here. What's hot mean? Go ahead. What did you say?
Not cold. Burn.
Opposite of cold. Burn. Somebody said burn.
Sweat.
What is it? Sweat. Okay. What else? What is it?
Heat.
Heat. Who said that? Heat. You think heat? Okay, good. I like that. Heat. What else? Yes? Sunny. Okay. Well, I'll tell you, I came out of a place yesterday afternoon around 5, and it was hot, and there was so much sand in the air, it was like overcast, and it was not sunny, and it was really hot. It was disgusting. But that's fair enough. All right. That's what you did. That's fine. Sunny. Hot, sunny. Excellent. What else?
Humidity.
Humidity. Okay, I like that. I'm not sure if we've defined hot yet. Yes.
Boiling?
Boiling. I like that. Boiling. Okay.
Energy.
Friction.
Friction. Okay. Friction. I like that. That's a great word, friction. Very difficult word to understand in physics. I like that though. Friction. I like that. What else?
Energy.
Energy. Okay. Energy.
Dehydration.
Dehydration. Dehydration. What else? One more.
Temperature.
Temperature. Okay.
Wow.
Okay. Everybody, put your hand, excuse me, put your hand on the table really quick. What do you feel? Just what's the first thing you feel really quickly? What do you feel?
Cold.
Cold, right? You feel cold, right? Right? Yes? You feel cold. Now, do this. You ready? So you feel cold, right? Now do this. You ready? You ready? Keep going. You got this for like 60 seconds. I'm looking at the back clock. Okay, it's actually working. Wow, amazing. The back clock is working.
It's still recording. Just low battery.
Is stop recording?
No, it's still recording.
It's still recording though, but it says low battery. Okay, keep going. Okay. So I got it. You got another 40. It's only 15 seconds.
Are you serious?
Yeah, believe it or not, I know. Keep going. You're not going to burn yourself. Don't worry. All right, that's only 30 seconds. That's enough. Okay, go like this. What do you feel?
Warm.
Warm. I like that. Warm. Okay. All right. Let me get a computer so I can charge that. Okay. All right. Good. Now I want you to define for me hot and cold. Anybody? You touched the table. And you said it was cold. Right? Didn't you say that?
Yes.
Okay, good. Then you rubbed your hands together for 30 seconds, about, maybe a little more, and you said that it was hot. Okay. I just want to know what those two words mean, hot and cold. I don't want to know anything else. I just want to know what they mean. First of all, how did you determine something was cold? How did you do that?
You felt it.
Whoa, back up. What did you say?
You
You felt it. I like that. It's a feeling, right? Feelings, nothing but more than, right? You felt it, right? That is the first time in 35 years someone came that close. The first time. Who are you? What's your name? Are you from this planet? Thank God. Okay, good. Now, I thought there was an alien in the room. First time in 36 years anybody came that close. Okay, good. It's a feeling. What told you that that feeling was occurring? What'd you say? Who said that? Who said it? What'd you say? Nerves, right? You say nerves? Did you say nerves? Okay, so what did the nerves, may we say nerves? Nerves? May we say nerves? Yes or no?
Yes.
Yes, excellent. She's looking at me like, oh my God.
I just don't know anymore.
He's crazy, okay? He's crazy. Okay, now, so what came in contact with the nerve?
The table.
No, what?
The temperature.
Energy.
Table.
Friction. Friction.
Friction, okay, friction, okay. But you're going like this. Where's friction? Okay, I got it, okay. But here, okay. Or on table. What came in contact with the nerve? It's very simple. Somebody may have said it because so many people were saying things. What's coming in contact with it?
The temperature.
No, not temperature.
Table.
Table. Table. Okay, what else? Somebody may have said it, so I know someone's going to say, well, you know, I said that, okay?
Fingers.
What do you have in your body? You eat food.
Energy.
You have energy in your body, but we don't say you have energy. We say you have what? When you lose in the winter, you're losing
Heat.
heat, right? Don't we say heat? You're losing heat, right? Aren't you saying that in the winter you lose heat?
Yeah.
Did you say that? Okay. But somebody said energy, which is cool. That's okay. You said energy. That's cool. Okay. So what is coming in contact with the nerve?
Heat.
Heat, right? Okay, good, good. So if something's feeling cold, what happened? Tell me,
It's losing heat.
what's losing heat?
The cold.
It is you, okay? It is you. So you are not it. You are you. So you are losing heat, yeah?
Yeah.
So when it's cold, heat is passing
Through.
across the nerve endings, right? So this is it. This is outside. This is skin. Right? So when energy goes like this, that has the sensation, the feeling
A cold.
Wow.
That's it.
So,
Let me tell you something. Are you ready for this? You ready? Are you ready? That's it. That's it. First down. Yeah. Yes.
so is that why, like, for example, when you get out of the shower and your, like, the droplets, you get cold because the heat's taking, like, the heat is leaving your body to dry yourself? Kind of?
And the air is colder than the shower water.
Okay, take that out.
What if you think
You know, let's not get too technical. But the answer to your question is, I think, in the order of yes, no, yes, yes. But the point is this, that's a little bit technical. Yeah, but if, like, for instance, let me answer your question in terms of something that you do every day. How many people sweat? Okay, it's a little weird if you don't raise your hand. Okay, everybody sweats. Okay, and why do you sweat?
It's hot.
You're what?
body
You're humans. Okay, you're not sweating because you're a human.
You come in contact
Good
with
sweat.
No, you want to reduce. Yeah, Will.
your body's cooling off body temperature.
Did you learn that in Paris? Where'd you learn that?
He's an athlete.
You know, stay away from your father. Okay, it's like too perfect. You gotta. People have too many expectations of you. You go around telling people that. Okay, all right, all right.
Body temperature.
Yeah, that's what you're doing. That's like perfect. Yeah, what are you doing? Say it again, Will.
Your body cooling off your internal temperature.
First of all, you sound like a textbook and it sounds really scary, okay? All right, fine. But that's exactly what you're doing. You are, and how is the body cooling off then? Hey, Will says, the water's evaporating, so you're cooling down your internal body temperature, okay? Well, it sounded like, that's what I heard, okay? So how does that work though? Let me tell you something, you ready? One pound of water. You don't know what a pound is, do you?
Yeah.
1 kilo of water.
What's a kilo?
A kilogram. 1 kilogram.
I don't.
1 stone of water. Okay, God, it's like
1 big rock.
multilingual. 1 big rock, okay? 1 stone of water, 1 stone of iron, right? Right? What's going to hold more energy, the iron or the rock? Just intuitively, don't think. What do you think?
Iron.
The iron, right? Okay. Well, it's the water. Not only does the water can hold more energy, not only can the water hold more energy, the water can hold almost 10 times more energy.
Wow.
That's why you don't sweat iron. Can you imagine if you sweat iron? Everybody walking around like a...
Would that be like toxic?
Well, if you sweat iron and you live to the age of 17 or 16, it's not toxic, but everybody looked like a suit of armor. That would be like really weird. But the point is, what happened? Is it all right? Is it still filming?
Yes.
Okay. But the point is this, that water holds tremendous energy. Tremendous quantities of energy, so that's why you sweat. And then what happens is the water will evaporate, right? It's not going to go back in the body, is it? Well, it could, but I suppose, but it's going to evaporate, right? And where's it going to get the energy to evaporate? Your body. Your body. You get it? Okay? So you cool off. So your body is losing energy. When your body loses energy, it feels cold. How many people have ever been to some place where it's cold? Okay? You go out of the house, you're in northern Canada, you go out of the house, and you are like, you have a t-shirt and, I don't know, some shorts on. You're going to freeze. It gets really cold. Okay? How many people have ever heard of frostbite? Okay? What's the difference between frostbite and spilling a pan of really hot bacon grease on your feet? What's the difference?
Frostbite freezes your blood.
Absolutely nothing.
Oh, what?
What? Ooh.
I know, he was going to give me this technical explanation. It's absolutely nothing. There's no difference. Yeah, there might be a little bit different with the process. I know what you're going to say. You're saying, well, the frostbite is the frozen, your blood and your cells freeze. But it's not liquid anymore, is it? So what does the body see? The body sees, lost water, dehydration, right? Doesn't the body see? It still has water there, but it's ice, right? But the body says dehydration. I take my hand and I put it in a vat of bacon grease while it's boiling. What's going to happen to the water in my hand? It's going to boil and leave my body, right? Steam, right? I'm going to dehydrate my hand. What is a burn? A burn is a massive quick loss of water from tissue, from your body. And what happens? Do you ever take, yesterday one of the teachers did it, sulfuric acid in sugar. It gives off all the water leaves. Well, wait a second, there's water chemically in this. You ready? Okay, there's this water. You see, what's this? This is sugar, right? So you have sugar, and what happens if I take water out of it? What happens if I take water out of it? What am I left with?
The C6.
Is that a C or 6?
This is, I don't know what these, okay, C6, right? You're going to get what?
C6.
This is, wait a second, this is 6, no, this is 6. I'm getting confused. This is a 6, right? You're going to be left with this. So you're dehydrating it. How many people have ever gone camping and your legs and feet get so cold, your hands get so cold, they get numb. Yeah, they get numb, right? And what happens when they get numb? What happens when they get numb? You can't feel them. And then what happens when they start to get unnumb? What happens?
Tingles.
It tingles, pins and needles. How many people have ever felt that it gets painful? It's absolutely positively painful. That's right. That's because the tissue is rehydrating itself because of this dehydration. So what is the difference between the what? The frostbite or putting your hand into boiling bacon grease? What's the difference?
Nothing.
Absolutely nothing. Nothing. Okay? Now, we're going to end this here as kind of like an intro to temperature. Okay? But there's actually something I want to do relative to, we're going to do this. You ready? We're going to do this. We are going to derive, what are we going to derive? How do I change from Fahrenheit to Celsius temperature or Celsius to Fahrenheit or anything like that? How do I do that? Has anybody ever done that before? Raise your hand. Converting between temperatures.
Oh, I think it's.
Have we done that? Yeah.
Kelvin Celsius, not Fahrenheit Celsius.
Fahrenheit to Celsius or Celsius to Fahrenheit?
Kelvin Celsius.
Kelvin Celsius you've done? Have you ever done Fahrenheit Celsius? Well, we're going to do Fahrenheit Celsius. Do we really care? This is a science class. Do we work with Fahrenheit?
No.
No, we work with Celsius. But there's this really annoying country out there that insists on using Fahrenheit. It's really annoying. I won't say what country it is. It's really annoying that they think they control the world and they use Fahrenheit. So a lot of literature, scientific literature, can be in Fahrenheit. So it's important to be able to convert between the two. But is the importance to be able to know what Fahrenheit is in Celsius? Is that the point of today's lesson? What's the point of today's lesson? No, the point of today's lesson is to derive the equation. It's a practice at deriving an equation in science. Okay? Can I end this? Part 1, temperature. Clear? Okay, good. So do you think it's important to know a little bit about temperature?